Welcome to a brand new explainer. Today, we are pulling off the ultimate academic heist. We are cracking the vault on the Cambridge Computer Science and Information Technology syllabuses. Whether you are taking 0417, 0478, 2210, 9618, or specifically the 9626 Information Technology course, the strategy we are unpacking today is your master key. We're targeting topic 14.9, encryption, access rights, permissions, and firewall configuration. But we're not just reading textbook definitions today. No, we are assembling a team of cognitive specialists to pull off the perfect answer heist. I want you to imagine two completely different students taking the exact same exam right now. Let's call them Alex and Sam. Alex is our data dumper. Alex overloads every single answer with raw computer science facts, but provides zero actual analysis. On the other hand, we have Sam. Sam is the rusher. Sam rushes through the paper, completely misses the specific command word requirements, and writes one-sentence answers that barely scratch the surface. We're going to look at their flawed answers, break them down, and show you exactly how to transform a red ink disaster into a perfect green checkmark masterpiece.
So that brings us to the million-dollar question. What truly separates a B student from an A-star candidate in these Cambridge exams? You might think it's just raw memorization of terms, like knowing the difference between public and private keys, or having the textbook definition of packet filtering memorized word for word. But that is a massive trap. Alex knows all of those facts, and Alex is still sitting at a B. The real difference is knowing exactly how to execute the examiner's rigorous grading blueprint. It's about taking those complex technical concepts and mapping them directly to the specific command words in the prompt. It's about understanding how the technology works behind the scenes, applying it to a completely novel scenario, and structurally proving your point. Today, we are giving you that exact blueprint.
To pull off this heist, we need a flawless step-by-step plan. We will start by decoding topic 14.9 to understand the foundational framework. Then we'll cover the core IT principles and dive deep into the method mark strategy. After that, we are running an interactive workshop on mastering critical analysis, mapping out the top examiner traps you absolutely need to avoid, and we'll wrap up with the ultimate exam success formula. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Section 1. Decoding Topic 14.9, the Foundational Framework.
Okay, let's dive into this insider intel straight from the examiners. The principal examiner reports explicitly state, candidates referencing cross-topic connections achieve significantly higher marks. This is exactly where our friend Alex goes wrong. Alex treats every question like it exists in a vacuum, but the crucial point here is that top marks require precise definitions, understanding causal relationships, and connecting topic 14.9 to other areas of the syllabus. For example, how does encryption actually impact network speeds? Well, encrypting and decrypting data requires significant processing power. That means implementing high-level security often introduces network latency. If you get a question about setting up a secure network for a video conferencing startup, and you recommend heavy asymmetric encryption without mentioning the potential impact on real-time video streaming latency, you are losing marks. Connecting security protocols to networking and hardware concepts is the master key to unlocking those top grade boundaries.
Section 2. Core IT Principles, Cognitive Domains.
Let's look at how the Cambridge Assessment Framework targets distinct cognitive domains over superficial breadth. Grasping these is absolutely essential. The exam prioritizes deep, analytical depth and systematic reasoning. It starts with knowledge and understanding of concepts like access rights, but it immediately pivots to application to scenarios, high-level analysis, and evidence-based conclusions. Remember Sam, the rusher? Sam sees the word firewall and just writes, "A firewall blocks hackers." That is base-level knowledge. It completely ignores the command word, which might be evaluate. To evaluate, you have to logically reason through whether a hardware or software firewall is better for a specific remote work scenario outlined in the prompt. You have to prove your conclusion with solid technical evidence. To do this, top students use the PELL framework: point, evidence, explanation, link. You make your point, back it up with technical evidence, explain how it works in this specific context, and link it back to the question. Analytical depth, structured perfectly, wins every single time.
Section 3. Method mark strategy. Technical methodology.
Now we are moving into the transformation phase.
Let's walk through the strict, standardized sequence required to secure every possible method mark during processing. Imagine an exam scenario where a company's sensitive data was intercepted while in transit between two offices. Let's fix Alex's approach. First, identify the key elements: data in transit, interception, two distinct locations. Second, apply the relevant principles. The data wasn't encrypted, or the encryption was too weak. Third, execute your analysis with clear working. This is where you explain exactly how implementing an asymmetric encryption system utilizing public and private keys would have secured that data payload. Fourth, verify your results against the scenario's constraints. Does the company have the infrastructure for this? And fifth, present it in the appropriate format. If you skip these steps, you leave massive points on the table, even if your final conclusion that they need encryption is technically correct. What's really interesting about these requirements is how strictly examiners enforce presentation conventions to award maximum points. We're talking about proper headings, correct terminology, appropriate formats, and clear annotations. If you have the right technical solution, but your presentation is a disorganized wall of text, the examiner literally cannot award you the maximum points. Clear structure equals clear marks. And speaking of clear structures, stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 4. Critical Analysis, the evaluation phase.
We've reached the interactive workshop phase of our explainer. I want you to look at this comparison and challenge yourself to consider why evaluating evidence is the absolute hardest part of the exam. Let's do a quick data scan challenge in our heads. Think about symmetric versus asymmetric encryption. A standard answer, like something Sam would write, just identifies basic similarities. Both symmetric and asymmetric encryption secure data so hackers can't read it. Okay, maybe you get 1 mark for that. But an A-star candidate? They identify similarities and differences using comparative connectives. They write, while both methods scramble plain text into ciphertext, symmetric encryption utilizes a single shared key, making it significantly faster and less resource-intensive. However, asymmetric encryption utilizes a mathematically linked public and private key pair, which, although slower, provides superior key distribution security over untrusted networks. Do you see the difference? The top-scoring answer questions assumptions, considers alternative perspectives, and justifies every single technical decision with evidence.
Section 5. Top Examiner Traps. Principal Mistakes.
It is time to look at the security alarms. These are the biggest pitfalls that instantly cost students marks. This right here is a massive, glowing red flag straight from the examiners. They note that candidates consistently confuse key terminology. You would be absolutely amazed at how often students mix up the specific vocabulary for encryption with the vocabulary for firewalls. Sam does this all the time when rushing. Remember, encryption mathematically scrambles data so it is unreadable if intercepted. It does not stop someone from stealing the file, it just makes the file useless to them. Firewalls, on the other hand, inspect and filter network traffic based on a set of rules to block unauthorized access in the first place. The firewall is the bouncer at the door, encryption is the secret language you speak once you're inside. The strategy to avoid this trap is simple but highly effective. Always define your terms clearly before you start throwing them around in an extended multi-paragraph response.
Let's play a little Find the Flaw with these top 3 mistakes identified in the principal examiner reports. Number 1, using the wrong approach for the wrong context. If the question outlines a scenario about a small local bakery with 3 computers, do not recommend a massive enterprise-level stateful inspection hardware firewall. That shows the examiner you have knowledge but absolutely zero application skills. Number 2, forgetting to check format and presentation. We already discussed how vital that is. And number 3, providing answers that are not specific to the given context. Let's do a speed writing challenge right now. Imagine you have 30 seconds to explain how to secure a hospital's patient database. If you just define what role-based access rights are in general terms, you fail. To get the marks, you have to say, role-based access rights should be implemented so that a receptionist only has read access to appointment times, while a senior doctor has read and write permissions from medical histories. Context is absolutely everything.
Section 6. Exam Strategy. The Success Formula.
We are bringing everything together now into the final operational system. Consider this your ultimate cheat sheet summary to guaranteed top marks. There are 3 underlying rules you must follow. First, command word decoding.
You have to know exactly what the prompt is asking you to do. Are you describing, explaining, or evaluating? Second, PO framework application. Make your point, give your evidence, explain it, and link it back. Third, you need a time management matrix so you don't end up rushing like Sam. When you apply this to a complex question, you follow these 5 steps. Step 1, deconstruct the question to understand the core need. Step 2, extract relevant data from the scenario. Step 3, select your analytical framework, like pairing a firewall with strict access permissions. Step 4, execute with clear, logical notation. And Step 5, present with precise, predefined terminology. If you follow this exact systematic logic, you will dramatically improve your grade boundary.
So, as you step into the exam room, ask yourself this final question. If an organization implements flawless, military-grade encryption on all their servers, but has incredibly poorly managed user access rights where everyone shares the same admin password, are they truly secure? Of course not. Master the intricate relationships between these concepts, connect the dots, and the top marks are yours. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly explainer videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science or IT and tell us the biggest challenge you're facing right now. Our team responds to every single comment. Like and share this explainer with a study partner. Ace the Exams. Your Cambridge success starts here.